This edition of Comet Algebra was made to help you with your summer packet when you reach the part where you need to use the quadratic formula. Now, if you recall, the quadratic formula is used when you have a quadratic that cannot be factored. So I rewrote the quadratic formula here just for you to look at. X is minus b plus or minus the square root of b squared minus 4ac all over 2a. Might be a good idea to get to know that, be familiar with that. It is up on the wall in my room, but some people prefer to memorize it. So the steps that we follow. First, you want to, if the equation is not equal to 0, you want to put it in standard form and set it equal to 0, so that makes it easy for us to find the values of a, b, and c. Now, if you're not remembering the word coefficients, the coefficient is the little number that sits in front of the letter. So something in standard form would, I'll just throw in a minus sign here, would be the x squared term first, then the x term, then the constant, and then having that equal to 0. A then is this little number that's sitting in front of the x squared, b is the little number in front of the x, and c is the constant. So you find those and then you put them in, plug them into the correct place in the formula, solve it for x, and then simplify the radical. So perhaps the easiest way would be just to look at some examples now. Looking over example 1 here, we can see that this is not in standard form, so that's the first thing we're going to do would be to subtract a 5x from both sides. And then the second step is identify your a, b, and c. I really want you to write it down, be very, very obvious here with yourself. So that when there is no number in front of an x squared or an x, we know that the coefficient is 1. The b in this case is -5, and the c is a +4. So now plugging them into the correct place, I'll be a little as obvious as I can here. We have minus b, so you gotta be careful. So we have minus a -5. Watch your double negatives. Plus or minus the square root. Now b squared is -5 squared minus 4 times a times c, all over 2a, which is 2 times 1. So let's do some simplifying now. The double negative becomes a positive, so I have 5 plus minus. Now looking under the radical here, whenever you square a negative, of course it becomes a positive number. In fact, this first number under the radical is always positive, because if you square a positive, it's positive. Square a negative, it's positive. And now this minus 4 times 1 times 4 would be a -16 all over 2. Go ahead and subtract the numbers under the radical. We get a 9. This one worked out pretty nicely. It usually doesn't, but this 9 is a perfect square. So I end up with 5 plus minus 3 over 2. Now this last step I call do the math. You need to split this up into the plus and the minus. Remember, a quadratic has two answers. This exponent of 2 is screaming at you, hey, find two answers. So we write out the first one with the plus sign. The first answer is 5 plus 3 over 2. 8 divided by 2 is 4, so that's our first answer. The second answer we write with the minus sign. 5 minus 3 over 2. Let's see, 2 divided by 2. The second answer is 1. So now we have found both answers for this quadratic. All right, let's look at one more example. And I believe I picked one that's not going to have a perfect square. So a little more challenging. Once again, write it in standard form. Identify the a, b, and c. And then plug them in the correct place in the formula. So I have minus b plus or minus the square root of b squared, 12 squared, minus 4 times a is 4 times c is -11. Oops, there we go. All over 2 times 4. So now we need to do some simplifying. Nothing to do with the negative 12, but under the radical, you need to square the 12 to get 144. Now this is where students sometimes mess up. This is a negative 4, and this is a negative 11. So you have a negative times a negative. Some people want to use that negative there and then use a negative again down here, but be careful. This is just a negative 4. So if you multiply negative 4 times positive 4, you get negative 16. And negative 16 times negative 11, if I did my math right, I got a positive 176 all over 8. So we still have some more simplifying, obviously. Go ahead and add those two numbers. And if I added correctly, I got 320 all over 8. Well, now, I'm hoping you remember your skills here. We need to simplify this radical. So we learned two methods. Either you have to find the biggest perfect square that goes into it, or you need to use a factor tree. For our example here in the video, I think I'm going to go ahead and do a factor tree just to help review that skill. So obviously it's even number, so I always go with the 2's until I run out. So half of 32 is 16, so this would be 160. Half of 16 is 8, so that'd be 80. Half of 80 is 40. Half of 40 is 20. Half of 20 is 10. And we finally get down to our primes. Now remember, we're doing square roots. Pairs are squares, so we actually do have many, many squares here. We have a pair of 2's here, a pair of 2's here, and another pair of 2's. So the square root of each of these is 2, because the square root of 4 is 2. So I have 2 times 2 times 2, which is 8, and then this 5 is left over. So let's now rewrite this. Negative 12 plus minus. Remember, I multiply all the squares that I found. That's why I went 2 times 2 times 2, and I got 8, and there is a 5 left over. That means that the largest square that goes into 320 is 64, and if you want to check that, 64 times 5 is 320. So really that's all we did. We took the square root of 64 is 8, and we left the 5 behind. Now, this is where you will hear me scream at you, well, not scream, but insist quite loudly, that you have 3 terms here. This negative 12 is a term, this 8 square root 5 is a term, and this 8 is a term. You can only reduce all of them, or you can't reduce them at all. So this is what I call an all or nothing. This 12, 8, and 8, they all share a 4 in common. So we're going to take a 4 out of this term, a 4 out of this term, and a 4 out of this term. So if I divide negative 12 by 4, I get negative 3. Keep your plus minus sign. 8 divided by 4 is 2. Remember, 2 square root 5 is a number, and I'm just working with the real part here, this 8. And then 8 divided by 4 is 2. Now, this is perfectly acceptable. I'm fine if you leave it in the plus minus form. But every year I have some students that are bothered by the fact that there's a 2 right here and a 2 right here, and they want to split this up into 2 fractions. They prefer to go a little further. So what they want to do is take that negative 3 and put it over its own denominator of 2, and then keep the plus minus sign and put the 2 square root 5 over its own denominator of 2. Now these two are perfectly fine, and they would only do this because they want to be able to divide out these 2's. And so Some people prefer to write this answer as -3/2 plus minus square root 5. This is also a perfectly acceptable way to write these answers. I would accept either one, and if you were asked to find the decimal equivalent of that, you could punch either one of these into your calc and find that. All right, that was our review of quadratic formula. So have fun finishing up that summer packet.